What is convection? Heat transfer explained. Imagine a warm breeze flowing across your face on a sunny day or steam rising from a hot cup of coffee. These are everyday examples of how heat moves through fluids. Today, we're going to explore how this process works and why it's so important in energy transfer. Convection is a way heat moves through liquids and gases. Instead of just spreading out from one molecule to another, it involves the bulk movement of the fluid itself. When part of a fluid gets warmer, it becomes less dense and rises. Cooler, denser parts sink down to take its place. This creates a continuous cycle called a convection current. Think of it like a giant loop of moving fluid that carries heat along as it flows. In natural convection, this cycle happens because of temperature differences inside the fluid. For example, when you heat water in a pot, the water at the bottom gets hot first. It rises because it's less dense, and cooler water moves down to replace it. This process keeps going until the entire pot heats evenly. That's why boiling water has those swirling patterns. Forced convection is different because an outside force helps move the fluid. Fans, pumps, or mixers are used to speed up heat transfer. When you turn on a fan to cool down a hot room, the air moves faster, carrying heat away from surfaces more quickly. This is why forced convection is often used in cooling electronic devices or heating systems. The speed of heat transfer by convection depends on several things. The bigger the temperature difference between the surface and the fluid, the faster the heat moves. The properties of the fluid, like how thick or sticky it is, also matter. Thinner fluids flow more easily, transferring heat more efficiently. The faster the fluid moves, the more heat it can carry. The size of the surface area involved in the process also plays a role. Scientists describe convection with a simple rule called Newton's law of cooling. It says that the rate of heat transfer is proportional to the temperature difference between the surface and the fluid. The bigger the difference, the faster the heat moves. This law also includes a heat transfer coefficient, which depends on the fluid's properties and how fast it flows. Convection is everywhere. It helps warm our homes with radiators, cool our computers with fans, and even influences weather patterns in the atmosphere. Inside the Earth, convection currents move magma, shaping the planet's surface over millions of years. So, in simple terms, convection is how heat travels through fluids by moving the fluid itself. It's a natural and essential process that keeps our world functioning, from boiling water to shaping the weather. Understanding convection helps us design better heating and cooling systems and explains many natural phenomena we see every day.